you have your take-home portion to hand to me. If you turn this in today, I give you like 1 point extra credit. If you want to keep it and bring it next class, because you're like, ooh, I don't feel great about this, I will accept it next class with no penalty, but there's no extra credit opportunity. So it's up to you. You are ready, if it's done and you're ready, turn it in, and I give you an extra point of extra credit for turning it in and being ready on time. What's that?
Like just returning it in with the extra credit?
1 point. But
Oh.
we'll take home test points. If you turn it in here today, you're ready to go. 1 point EC on it. You want to keep it for next class because you don't feel good about what you did, or you feel like you still have a lot of work to do on it, or
Are we gonna talk about this today or not?
not if everybody's not turning it in, right? So yeah, that's up to you, right? Is everybody okay? Was there anybody absent that didn't get this, the take home test points? I gave it to him in accounting the other day, because I see him every Mark, you haven't gotten one? Alright. The other thing I passed out last class was these accumulation practice problems, right? Does anybody need one of these? Probably Mark. Anybody else? Okay. What I'd like to do, we have 5 of these. What we're going to do today, I'm going to divide you into 5 groups and assign your group one of the 5 problems. You're going to work it and post your answers, and then we'll read through them and make sure everything looks good. And if it's not, we'll make some corrections and call it a day. Everybody feel okay with that? Alright, so let me get the groups assigned first. And I'll show you where we're going to do this at. Get this set up because I'm flying a little bit by the seat of my pants right now, but that's okay. This is second hour. Stage roster, random group. Group 5 groups. Here we go.
Coffee, your hair. Oh, you're gonna have it.
He went to IT. Feels like a very Marcelino thing to do. Just where did he go? He just disappeared.
Would you love to do that?
Then why did you make it sound like there is a so yes. Wait, I don't know.
All right, so we're gonna be using your OneNote. So at least somebody in the group's gonna need their OneNote up and open. And we're gonna be, for the first and probably only time, gonna be working out of the collaboration space in our OneNote. Because you guys are gonna be writing this in, and we'd like for the other students to be able to look at your stuff afterward. So it'll just be easier that it's kind of all in one spot.
Is it hot in here or is it just like? No, I'm so You're always hot. It's probably because you're cold too.
It's probably because you're like not wearing a skirt
Oh,
for like the only time. It's like, oh my gosh, I have actual real cold and covering my body.
I do. This is very fuzzy.
All right.
Why are you laughing? That's not appropriate.
So these are the group assignments. Group 1, you're going to do problem 1. Group 2, problem 2. Group 3, problem 3. Group 4, problem 4. Group 5, problem 5. Find the people you've been assigned with. Find a space. When you look at number 1, 2, 3 or whatever, it's in there. Feel free to work on a separate sheet of paper and transfer it in if you'd like, or you can work directly in the OneNote. It doesn't matter to us. We'll do this for say 20 minutes, and then we'll start kind of unpacking things, okay? Sound good? Sure. Been writing your stuff into the, okay, so these guys have got some stuff in here.
Nobody's gonna know that it was.
Okay. All right, so you guys, everybody take a look at problem 1. We're gonna kind of go through what group 1 did, talk about stuff that was right or wrong, good or bad. If there's mistakes, we'll make some corrections. Nobody's expecting to do this perfectly. Nobody's gonna have all the right answers, probably. So don't be embarrassed. We're not trying to embarrass anybody. We're just trying to get better at how to think about this stuff. And the best way to do that is to see where you're at and then get some expert feedback as to what you've done good or bad, right? It's just about learning. There's no points attached to this. It's not a contest. It's just about learning and getting better at this stuff, right?
Is this gonna be kind of like the FRQ on the test?
I will tell you the FRQ format for the test will be identical to one of these 5 problems, short of different numbers,
Okay,
right? But the setups will be identical.
okay.
Okay, this is a very common presentation. All right, so number 1 reads, there's 700 people in line for a popular amusement park ride. When the ride begins operation in the morning, once it begins operation, the ride accepts passengers until the park closes 8 hours later. While there is a line, people move onto the ride at the rate of 800 people per hour. The graph above shows the rate to R of t at which people arrive at the ride throughout the day. Time t is measured in hours from the time the ride begins operation. How many people arrive at the ride between 0 and 3? Show the computation that leads to your answer. So you guys have the correct answer here. I would say that the showing of computation is a little bit lacking. So what I would say would make this better is you'd say that what you're really doing, do that for me, please, is we're doing the integral from 0 to 3 of r of t dt, right? That's better. So if I'm looking from 0 to 3, I'm looking for the shape of this figure. Is everybody okay with that? And then you can do this calculation kind of any way you'd like, whether you want to break it up into triangles and rectangles or trapezoids or whatever. When I did this, I thought about this as two trapezoids, right? This is T1 and this is like T2. So I have 1/2 base 1, which is 1,000, plus base 2, which is 1,200, times the height, which is 2. And then the next trapezoid, 1/2 base 1, which is 1,200, plus base 2, which is 800, times the height, which is just 1. Okay, so they have like the simplified version of this. When they say show computations that lead to your answer, I would want to do a little bit more than just write the numbers that I added together to get the answer. If that's probably a 2-point problem, you would have gotten 1 out of the 2 for the correct response, would be my suspicion. Is everybody okay? All right. Part B says, is the number of people waiting in line to get on the ride increasing or decreasing between time 2 and 3? Let's see what you guys did here. This is probably the most challenging of the 4 questions, I thought. Between 2 and 3, t is increasing. What is t is time. So like that's between t equals 2 and t equals 3, right? This should probably, you mean this to be t. And this is probably like the people in line is probably what you mean there, right? Okay. Is increasing because the people per hour is higher than the rate that people move onto the ride. So that's good, right? So between t equals 2 and 3, we're looking at this section, right? We know that the rate people enter the ride is 800. At that time, we're greater than 800, right? So I would say that the better way, I would say increasing, because the population total is going to be the population in minus the population out. So the rate at which that's happening would be the derivatives, which is going to be r of t minus 800. And I want to show that that's greater than 0. So basically, I just need r of t greater than 800, which we have for, for t on the interval from 2 to 3, right? So that's like a really simple-y way to say it. I wouldn't, the thing that would make this better it's just use some of the names that they give you in the thing and some of the values they give you in the question. So because, for t between 2 and 3, the people in line is increasing because the people per hour, or because r of t is higher than the rate at which people move onto line 800. And I think that's a good answer, though. You did a nice job. It's good. It's good. I think that would have gotten the full mark on it, to be honest with you. I'm just talking about like ways of communicating a little bit more clearly. But this is good. This is your first time doing this, right? No problems. Part C, it says, at what time t is the line for the ride the longest? How many people are in line at this time? Justify your answer. What are we doing in here? This is an optimization problem, right? Everybody catch that? Because how do I know it's optimization? We're looking for when the line is the longest. We're looking for the maximum, right? So we're going to start by writing our equation for the people in line, which is what we did here, looking at where the derivative is equal to 0. Which is the same thing for where this. So I'm basically just looking for where the people entering the line is equal to 800. If I go back up to here, there's one spot. That's t equals 3, right? Ready to catch that? And how do I know that this is a maximum? If I look at a second derivative test here, the slope of r of t is negative, which would tell us that this value is a maximum. All right, let's see what you wrote. At time t equal 2, so you have the wrong time. So I think that that's probably going to be, I probably don't need to read past that, right? Do you guys see what I did though, in terms of?
So why is it not?
So
Wouldn't the accumulation of people in the line be the greatest at that time?
So if I'm looking to maximize a function, we've written a function for the number of people in line, right? People in line minus people out of line, that's going to give us the total number of people in line at some specific time. If I look at the derivative of it, that's going to be the rate at which people enter a line minus the rate at which people leave the line, which is r of t minus 800. I'm going to set that equal to 0 to find the critical point. So I'm looking for where r of t is 100, or is equal to 800. That happens exactly at x equals 3. That's my critical point. That's the only possible value outside of the beginning and end, which I should probably also check since it's a closed interval. Does that, Lucas, does that answer why it can't be 2?
Yeah.
Because even after, after 2 hours, we still have more people entering than we do leaving, so the line's still going to continue to get longer. Right? Does that make sense?
Yeah.
Okay. Even if it's at the peak of people entering, we still have more people entering than we do leaving after 2 hours, so it's still going to the line's still going to get longer. Part D says, write but do not solve an equation involving the integral expression of r, whose solution gives the earliest time t in which there is no longer a line for the ride. So let's see what you guys did. And this is, other than a little bit of notation, this is good. So the only thing that I would say that needs to be fixed, this should just be r of x, and this should be dx, and there should be nothing there. So you're just looking at the integral from, or 700 plus the integral from 0 to t of r of x minus 800 dx equal to 0. That's it. Oh, we didn't do the how many people are in line. So the number of people in line then would be 700 plus the integral from 0 to 3 of r of t dt, which was 3,200 from part A. Oh, shoot, minus 800. Yeah. So we would have been 1,500. Sorry. All right. On to number 2. Who did 2? You guys did? Okay. So reading this, it says a certain grocery store opens, it has 50 pounds of bananas on display. Customers remove bananas from the display at a rate f of t, yada, 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 where f of t is measured in pounds per hour and t is the number of hours after the store is opened. After the store has been open for 3 hours, employees add bananas to the display at a rate modeled by g of t equals yada, 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 where g of t is in pounds per hour and t is the number of hours. A, how many pounds of bananas are removed from the display during the first 2 hours the store is opened? So you're going to just do the integral from 0 to 2 of f of t dt, which should give you 20.1 pounds. That's good. So you could just, you could also have just written, like, on your paper, you could just write this. Like, you can use the notation that they have. Not wrong to write it all out, but in a time setting where it's like, if I can save, a couple of minutes by not having to write out these long, complicated functions every time I have to do something, if I'm just going into the calculator anyway, like, feel free to do that kind of thing. Part B then says, find f prime of 7. Using correct units, explain the meaning of f prime of 7 in context of the problem. So you have the correct value here. This is, the unit should be, I don't think you left.
Per hour.
That's incorrect. It's going to be pounds per hour squared. Pounds per hour, because you took the derivative of a rate. So the rate for f of t, or f of t was in pounds per hour. If you take the derivative again with respect to t, it's pounds per hour. Okay, so you did need that. This means we are taking bananas away at a rate of this. No, that's not going to be it, because that would just be what f of t is. F of t is the rate at which bananas are being taken away. So I would say something like after 7 hours, the rate at which bananas are being removed is decreasing by a rate of 8.12 pounds per hour. So it's a rate of a rate. You need to make that clear in your explanation that you're looking at a second derivative.
Wait, so after 7 hours, the rate at which bananas are being removed
is decreasing by your number.
Okay.
Does that make sense? Because now we're talking about a rate of a rate, because you're talking about the rate decreasing. Or you could say the rate of the rate at which bananas are being removed is negative 8 point, and that would be fine, I think, also. But you need to make it clear that it's a second derivative, which you did not do in here, in your words. And that's all we can read is the words, right? You did the right thing, though. Good. All right, part C says, is the number of pounds of bananas on display increasing or decreasing at time t equals 5? Give a reason for your answer. So again, like, bananas total is going to equal it'd be the 50 plus the bananas in minus the bananas out, right? So the rate of that.
Wait, just asking for
So if you're looking at whether it's increasing or decreasing, you're looking at the rates of these things. And this is just f of x minus g of x, and you just want to know, is it positive or negative, right? And it looks like maybe that's what you were trying to do. Because you got, where did it go? So this is the number that I got. So the number is decreasing. That looks good. So down here, it looked like you had a plus here and then changed it to a minus later on, but you have a minus here. That looks okay. So good job there. I'd say that explanation is satisfactory. Part D, how many pounds are on display at time t equals 8? So you got 23.3, that's correct. The big thing that is easy to screw up is that the leaving function doesn't begin until after the store's been open for 3 hours, or their restocking function. And you have the 50 to start, so that's good. Oh yeah, we have these going the wrong way. That's what you're gonna argue about. Yes, thank you. So that's minus plus. Okay, but that looks good. So other than like a little bit of communication issue with your writing and your unit, everything else there, the math looks pretty good. So good job, guys. 3, who is my group 3? You guys, all right. At an intersection, is it time to go?
Yeah.
Okay, we have 1 minute. Okay, well, I think, hold on a second, guys. If I look in the content library, and I look here, I just want to double check that this is indeed here. If I look at the accumulation FRQs key, I have the AP keys for these 5 problems. So you can go through and read through and check against what you guys did. Now it's the AP version, so like it's kind of hard to pick out where the work is and what the answer is, but that's there. Sorry we didn't get enough time to go through everybody. It's 20 minutes. I had to give you guys enough time to try stuff, and I think you trying stuff is more beneficial than just watching me do it. So that stuff is on there. Please check. Again, the FRQ on your exam, which is Tuesday, will follow the format of one of these 5.
Wait, you have a test next class?
Yes, the test is next class. I know. We gotta get it in before these kids leave for Kairos again. You know? I feel like that really torpedoed everybody last time. That had to take their test.
I could definitely.
Sam.
Yeah. They're rough. So. Look at the OneNote. And if you look at the bonus integration techniques, that'll have some examples of stuff that you want to look at.
Okay.
Okay, so take a look at that one. Those techniques for that first part will all be examples.
Is this up there too?
That's area between curves or volumes of rotation. Not in this one, but you know, you look at the volumes, or there's a couple different volume techniques on there. So that covered 6.2, 6.3, and the bonus or the other cross sections examples. Yeah.
I was just gonna ask, could you maybe assign some delta math for the difference between like the shells, the disc, and the washers?
So I don't think Delta Math had shells.
Okay.
I did already assign
The one worksheet.
the Delta Math with, hold on, let me pull it up. Because I did assign you guys already a Delta Math for.
Yeah, I think there was one for the disc washers. Yeah, that was helpful.
And I think that you should be able to go back into this Delta Math and just read some of these prompts. Like do that again, do some different thing. Like
Yeah.
I don't think there's a limit. Probably
Yeah.
not going to attempt it. It shouldn't be closed. If it is, let me know and I will go in and make sure I can reopen it.
Okay, sounds good.
Does that feel okay?
Yeah. Okay, thank you.
Yes.
Alright, have a nice weekend.
Meredith, did you have moral support or are you waiting to talk to me? Okay. Have a good day then, morals.
Oh my God, not a good time.
Bro, he's vaping.
Cade was diagnosed with a collapsed lung.
Oh, what?
Cade Cunningham,
Oh.
Extended,
problematic.
how do you collapse his lung?
Yeah, how did that happen?
Try vaping
Wow.
too much.
Yeah, it's a bad timing with the playoffs
Oh,
here
very
imminent.
bad. It's okay, they don't need them.
You don't really need a
They don't
lung
need
to
it?
play
They
basketball,
got it.
right?
He doesn't need it. He can go with one.
Yeah, lung transplant and everything.
I just.
I'll go to my lung. My lungs aren't bad.
Oh no, not the optimization. I just need to like look
You,
at
as
my
long
notes.
as it's in the folder before you leave today, it's,
Before we leave?
it'll be
Okay.
accepted.
Are we working on it during class?
No. But, well, I'll tell you the deal here.
Because I tried and I just.
It's okay, take a deep breath, okay? You'll be happy with the compromise that I have, for you, okay? But I'm gonna wait till everybody gets in here, just so I don't have to repeat it over and over. Is that fair?
Yeah.
Okay. So I think you'll be fine with that.
Yeah.
Did you see I sent you an email about the high scholarship thing?
No, I didn't.
Okay, so I sent it, I finished your letter and sent it off to Mrs. Dowd, so it should be all, from my end, it should be all set.
Okay, thank you.
No problem. Good luck.
Thank you.
You're welcome.
I'm almost done the application. I have like 10 more days.
Okay, so if he said, if he's like, let me know or whatever, and I can resend it, but he should have it.
Okay, I'm meeting with him like next week.
Okay, perfect.
Okay, I have to say
You have that, right?
Yeah.
Okay, and then what did we do after that? Okay, so once you see that this is like a square, you should be trying to make a inverse substitution, which is not what you're doing. So you're on the right track, that looked okay.
I'm so like.
But yeah, so you're right, trying to complete the square, that is what you want to do.
So.
And there is gonna be like some googly you gotta do to get crammed into the tan first. But that's the goal. Okay? So like this part up to here looks pretty good, or even to here, and then afterwards it okay, I would tell you that there's a little bit more work you have to do to get this to the tan first.
Okay, well, it's in there.
But you're pretty close.
Okay.
Okay?
Okay, I have no idea what I'm supposed to do.
Okay. So again, what you're looking for, if you go to the bonus integration techniques, like if you look at this example, and I think we did the same thing inside of, but that's an example there of what we're doing. So this was the section in the notes where this example lived. Okay? So that's a good starting spot.
I literally looked at this for like an hour and I couldn't figure out how to do it.
Mr. Floyd, do you know if we have to stay within our 4th hour during lunch?
I do not know what the lunch plan is.
I'm wondering if it's better in my class.
So, what technique are we using? Are we doing the washer? Are we doing this?
Well, if you say
Okay, so that makes a big difference. Okay? So if it's absolutely. So if it's a washer, you have this, right? So you have the area tested, right? So you have like pi r outer, the outer minus pi r.
Wait, I want to hurt you. You know how to use
oh my gosh, yes, I've seen this on TikTok.
That's what
I bet I
you're
can do
trying
that.
to do.
Can
Yeah,
I,
it should be separate. It should not be
are you guys?
together. If it's a disc, that's where the ring is.
Wait, let me jump over the Let me jump over the
Then you have
back.
pi r squared.
Does it matter which one we do?
It absolutely does.
Because actually, they go so high, I've seen that. They go,
Depends on the shape.
Yeah, they go like up.
they go insane. I wish. I swear.
Depends.
That's what they like
So,
gallop.
Yeah, they do
I tried to like give you something
Wait,
where
wait,
But they go so high.
to make it
Trying to make it right.
quickly I'm rotating in about one
No, what kind of ride
Or I can make it a disc model, or I can make it a shell model. Just all depending on what.
Yay!
So So without reading the whole thing really carefully,
What's
you
that?
ask me to do that. You know, like, did I do this?
For the
right?
tickets?
You ask me questions and you don't really have that good answers, and so I can't give you a whole lot more feedback
I
than
always
that.
assume that like doctors are pretty much.
No, so like, what I would say is like, so you're rotating.
Think you can see us?
Right?
Hi.
And you have
What?
the shaded
What you looking
region.
at, boy?
The area is all touching the axis.
Gallops and a naze. She's having
So, but if you have something like
He has it. He's not cultured.
this axis, you see how like part of the shaded region isn't touching the axis rotation? That's not the goal.
Okay. What color? That's what I'm trying to figure out.
That's what
Like dark
I'm,
red.
when I'm looking
I
at
was
the
gonna wear
two-dimensional
dark red
picture, that's what I'm.
Wait, you should.
Okay.
It's like this is this.
I like
This gap here. Some of
But they're
the gaps between the axis rotation.
Oh.
That's the one I'm wearing.
Does that help?
I have the same top, but like my
Is this the right way to set up the inner and outer?
Assuming you're rotating about this axis,
Put the sound.
My mom's not.
except, which one is inner, which one is outer? Which one are like these two?
Was it me?
Yeah.
That's fine. Maybe it wasn't, I guess maybe not.
Yeah.
There's no arrangement. Okay, that way that tracks, that's why I thought it was, where was it? So.
You're already in college. Why should you? I don't know. That could go back in. My mom does the same thing whenever I want to do something like.
All right, folks, I think it's about that time.
Yeah, exactly.